All right, everybody, let's do this. So, a little section within chapter 2.2 I forgot to mention was certain types of graphs, and we'll go over them. But just a quick review, from the previous video, we talked about some sort of normal distribution, uniform distribution, some skew right, skew left. So that was in the previous video. That's what we talked about before, and the real life examples that we went over. For chapter 2-2, let's continue the types of graphs that are out there and how can we organize data, right? So before we get into that, here's some quick, so for this lesson, there's a lot of kind of notes involved, and I'll kind of just like go through it. And what I like you to do is each time I flip through the page, just pause the video, take a second, copy it down, and then continue on. Right, so the idea, these two quick definitions, we have quantitative data and qualitative data. So when we talk about quantitative data, think about things that consist of numbers or representing measurements. And qualitative data would consist of names, labels, etc., etc. So if I want to take quantitative data, I don't know, let's say how tall people are. Right? So let's say, let me get a little sticky note. So like if I want to talk about quantitative data, I can talk about height, temperature, anything to do with actual numbers, right? But if I have qualitative data, I wanted to find information of, oh, what's your favorite color, right? If I had blue, red, whatever the case may be, anything that doesn't have to do with numbers would be qualitative. But when we talk about actual numerical measurements, we're going to call it quantitative data. Yeah? Okay. Next part. Here, the first type of graph that we could talk about, I'm not sure if you've seen this before, maybe you have, but a dot plot consists of quantitative data, right? So we have numerical measurements in which data value is plotted on the point above a horizontal scale of values. So when we look at data values such as this, how do I interpret this dot? This would be maybe 40, then 41. And then I have three 50s, maybe a 51, 52, 53, whatever the case may be. But the idea of this is if you take a bunch of data values and you plot them on this horizontal line here, we call it a dot plot. What are some nice things about this? It displays the distribution, right? So when we talked about distribution in the beginning, we talked about this type of distribution. Notice how within this data, this kind of almost looks normal. Maybe the data values are a little more to the right side, but notice how we have a distribution of the data, right? And it is usually possible to recreate the original list of data values, right? So if I look at this dot over here, I know this is somewhere, in the low 50s, right? Okay. So that's a dot plot. Next one. Here, this one, it's funny, a stem plot or a stem and leaf plot. I remember learning this back when I was like 8 years old or whatever, like back in 3rd grade, but a lot of you maybe never learned this. But what is a stem and leaf plot? Let's say if I wanted to organize these data values, like let's say if I had 11, 23, 24, 37, 48, whatever, right? The idea with the stem and leaf plot is if you take your tens and you put them here, so if this is 1, 2, 3, 4, notice this represents 10, this represents 20, 30, 40. So how would I put this data value? This data value here represents 11. This data value here, if I have a 3 here, then it represents 23. If I wanted to put 24, I just put the 4 there, right? And let's say if I had a 22 in here, then I'm gonna have to organize the data values so that they're in order, right, from least to greatest. And if I wanted 37, I put the 7 here, and this is 48. That's it. That's a stem and leaf plot, and it has its own positives and negatives. This is a little childish, but that's one way of representing data, right? Let's go through another. Here, a time series graph, and remember, pause the video and please have this in your notes, right? So a time series graph, it graphs the time series data which are, notice that we have quantitative data that have been collected of different types. So if we talk about, let's say, law enforcement fatalities, notice how we could have some sort of data that depicts since 1985 to 2010, the fatalities by law enforcement, wherever it has been, it had some downward from 1990, then it went up and down. So this is really nice to see data from a time standpoint, okay? And yeah, that's a time series graph. Let's go with the next one. All right. Here, a bar graph is pretty straightforward. It's kind of like a histogram, but notice how if I have a bar graph, like the data value, like they don't have to be smushed together. Like you could just have some sort of quantitative data, and you could just put them in bar graphs, and yeah, this one's pretty straightforward. I'm pretty sure we've all seen a bar graph, right? For a Pareto chart, this one I don't think is as common, but the idea within a Pareto chart is, notice here we're going to talk about qualitative data. So notice we're not talking about numerical values, we're talking about non-numerical values, in which the bars are arranged in decreasing order from the frequencies. So if I wanted to talk about, let's say, stolen boats, right? And notice how jet skis were mostly stolen, then motorboats, then utility boats, then inboard boats, right? So the idea is you represent the qualitative data in descending order. So it'll have some nice visual to it to see which data values are highest to lowest, okay? And that's a Pareto chart. Here, a pie chart, pretty straightforward. You just take these data values, right, within, and you just make percents out of them. So maybe this is like 66%, this is 20%, etc., etc. Okay, we've all seen a pie chart before. And yeah, that's it for this section. Very short and sweet, with 2-2. This was just a very short video just to talk about some graphs. Within the next one, the final section within chapter 4, we'll talk about scatter plots and correlation and regression. And what I'll do is I'll just make that in a separate video. Okay, I'll see you in the next one.